Hello my lovely students, you're welcome to a new lesson. Today, I shall be teaching you simultaneous linear and quadratic equations. From definition, simultaneous equations are two or more equations that have common values and can be solved together at the same time. An example of simultaneous equations is as follows. We have two equations here. The first equation is 4x plus 2y is equal to 20, while the second equation is 7x minus 3y is equal to 9. This is an example of simultaneous equations. Let's learn more about simultaneous equations. Linear equation. A linear equation is an equation in which 1 is the highest power of the unknowns. That is, it's an equation of degree 1. The equation y is equal to mx plus c is a linear equation in x and y. The graph of a linear equation is a straight line. Quadratic equation. A quadratic equation is an equation in which 2 is the highest power of the unknowns. That is, it's an equation of degree 2. The equation y is equal to ax squared plus bx plus c is a quadratic equation in x and y. The graph of a quadratic equation is a curve known as a parabola. Let's see the methods of solving simultaneous equations. Number 1 involves algebraic solution. That is, talking about the elimination method and the substitution method. While number 2 involves graphical solution or method. Please take note of these methods of solving simultaneous equations. Let's see our first example, example 1, involving simultaneous linear equations. Solve the simultaneous equations 2x plus 5y is equal to 1 and 3x minus 2y is equal to 30. Let's see how the solution goes. Let the first equation 2x plus 5y is equal to 1 be equation 1, while the second equation 3x minus 2y is equal to 30 be equation 2. Now let's solve equations 1 and 2 simultaneously by elimination. Here I wish to eliminate x. How do we eliminate x in these simultaneous equations? To eliminate x, let's make the coefficient of x here to be the same. To do that, the coefficient of x in the first equation, which is 2, should multiply the second equation, while the coefficient of x in the second equation, which is 3, should multiply the first equation. When you do this, you are going to have the equations as follows. 6x plus 15y is equal to 3 in the first equation, while 6x minus 4y is equal to 60 in the second equation. Now we have the coefficient of x in both equations the same, which is now 6. How do we eliminate x from here? Let's see if you know what to do. To eliminate x now, we are going to subtract one equation from the other. Here we are subtracting equation 2 from equation 1. When you subtract, you are going to have 6x minus 6x being 0. That means x is eliminated. Also, 15y minus 4y will give you 19y. While after the equal sign, 3 minus 60 will give you minus 57. That means the equation reduces to 19y is equal to minus 57. To get y, divide both sides of the equation by 19. That makes y equal to minus 3. Now that we have gotten the answer for y, how do we get the answer for x? Of course, to get the answer for x, we are going to substitute the answer for y into any of the equations, either equation 1 or equation 2. Here, I'm substituting the value for y, which is minus 3, in equation 1. Substituting and calculating carefully, you're going to see that the answer for x is equal to 8. That gives the answer to the simultaneous equations in example 1 as x is equal to 8 and y is equal to minus 3. I hope this solution is clear to you. Please, do you know what you must do to check your answers here? Let's see if you are right. To check your answers in the simultaneous equations, you have to substitute your answers back into the question to see if the statement or the equation will be true. In equation 1, we have 2x plus 5y is equal to 1. We got the answers x is equal to 8 and y is equal to minus 3. If you substitute these values into equation 1, you are going to find that the equation reduces to 1 is equal to 1. Of course, 1 is equal to 1 is a true statement. That means that the two answers for x and y are very correct. Let's do the same thing for equation 2. Substitute your values for x equal to 8 and y is equal to minus 3 into equation 2, which is 3x minus 2y is equal to 30. You'll find that the equation reduces to 30 is equal to 30, which is also a true statement. That means that your answers x is equal to 8 and y is equal to minus 3 are very correct again. Please do ensure you always check your answers after solving your simultaneous equations. Let's see our second example for simultaneous linear and quadratic equations. Solve the equations. 3x plus y is equal to 10 and 2x squared plus y squared is equal to 19. The first equation here is a linear equation, while the second equation is a quadratic equation. Let's see the solution to example 2. Let equation 1 be 3x plus y is equal to 10, while equation 2 is 2x squared plus y squared is equal to 19. Let's solve the two equations simultaneously by substitution. In doing this, let's start working from the first equation, which is 3x plus y is equal to 10. Making y the subject of this equation, we have y is equal to 10 minus 3x. Let that be our third equation now, equation 3. Do you know what we must do with equation 3? Let's see if you know. Since we are working with the method of substitution, we are going to substitute 10 minus 3x for y in equation 2. That means substituting equation 3 that we got from equation 1 into equation 2. Equation 2 says 2x squared plus y squared is equal to 19. Since y is going to be 10 minus 3x, we are going to have the equation 2 as 2x squared plus, in brackets, 10 minus 3x squared is equal to 19. Here, y is being replaced by 10 minus 3x. This is the substitution that we refer to. Now, if you go ahead to solve this equation, what will be your value for x? Let's see if your answer is correct. Expanding the bracket for 10 minus 3x all squared and collecting your like terms, we're going to have the equation as 11x squared minus 60x plus 81 is equal to 0. Let's factorize this quadratic equation. Factorizing this quadratic equation and solving for x, the answers for x are x is equal to 3 or x is equal to 2 whole number 5 over 11. I hope you got these answers correctly. Now that we have gotten the answers for x, do you know what we must do to get our answers for y? Of course, we are going to substitute our answers for x into any of the equations 1, 2, or 3. If you substitute, what will be your answers for y? Once again, let's see if your answers are correct. Since x is equal to 3 or x equal to 2 whole number 5 over 11, substituting these values for x into equation 3, which is y is equal to 10 minus 3x, you are going to have when x equal to 3, y is equal to 1 from substitution. Also, you will have when x is equal to 2 whole number 5 over 11, y will be 2 whole number 7 over 11. I hope your answers are correct. So the summary of our solutions here are x equal to 3 and y is equal to 1, or x equal to 2 whole number 5 over 11 and y is equal to 2 whole number 7 over 11. I hope the solution to example 2 is clear to you. Moving on, let's learn about word problems leading to simultaneous equations. The steps required to solve word problems leading to simultaneous equations are as follows. Step 1. Read the word problem carefully. Step 2. Identify the two unknowns. Step 3. Form two equations from the word problem. Step 4. Solve the two equations simultaneously by elimination, substitution, or graph. The last step, step 5. It is useful to always check your answers by substitution. Please take note of these steps required to solve word problems leading to simultaneous equations. Let's see an example involving word problems leading to simultaneous equations. Example 3. The perimeter of the isosceles triangle in the diagram below is 28 centimeters. Question A. Find x and y. Question B. Hence, state the lengths of the sides of the triangle. We have a triangle here, an isosceles triangle. The length of AB is 4y centimeters, being equal to the length from A to C, which is 6y minus 2x plus 1 centimeters. The third side, BC, the length is x plus 2y centimeters. Let's solve this example. Let's see the solution to question 3a. From the properties of an isosceles triangle has two equal sides. From the diagram, the length of AB is equal to the length from A to C. That means that 4y, which is the length of AB, is equal to 6y minus 2x plus 1, which is the length of AC. Solving this equation by collecting like terms, you are going to have the equation be reduced to 2x minus 2y is equal to 1. Let's take this as our equation 1. Now from the question, do you know what you must do to get a second equation, which should be equation 2? Let's see if you know. From the question says the perimeter of the isosceles triangle is 28 centimeters. To find the perimeter of a triangle, we are going to add all the sides. That means the length of AB plus the length of AC plus the length of BC should be equal to 28 centimeters. Adding up these three lengths, collecting your like terms and simplifying the equation, we are going to have an equation 2, which should be minus x plus 12y is equal to 27. Now, having gotten two equations from this word problem, which are equations 1 and equation 2, let's solve these two equations simultaneously to find x and y in question 3a. Solving equation 1 and 2 simultaneously by elimination. Here I wish to eliminate x. To eliminate x, I'm going to make the two coefficients of x in both equation 1 and 2 to become the same. To do this, the coefficient of x in equation 1, which is 2, should multiply the bottom equation, while the coefficient of x in equation 2, which is 1, should multiply the first equation. When I multiply in this way, I'm going to have the two equations as 2x minus 2y is equal to 1 as the equation 1, y minus 2x plus 24y is equal to 54 as my equation 2. To eliminate x, I'm going to add the two equations. Now when you add the two equations, what are you going to find? Let's see. Adding the two equations, we're going to have 2x plus minus 2x, which should eliminate as 0. Also, you are going to have minus 2y plus 24y, which will give you 22y. And after the equal signs, you are going to have 1 plus 54, which should give you 55. So the equation reduced to 22y is equal to 55. To solve for y, divide both sides by 22. That will give you y is equal to 2.5 or 2.5. Now that we have gotten our answer for y, let's get our answer for x by substituting 2.5 for y into any of the equations. Here I chose equation 1. When you substitute 2.5 for y in equation 1, what will be your answer for x? Let's see if your answer is correct. From equation 1, we have 2x minus 2y is equal to 1. When you substitute 2.5 for y into the equation 1, you're going to have 2x minus 2 times 2.5 is equal to 1. Solving this equation carefully, you will have the answer x is equal to 3. I hope you got that right. So our answer for question 3a is x is equal to 3 and y is equal to 2.5. Now that we have gotten our answer for question 3a, which is knowing the answer for x and y, let's state the length of the sides of the triangle in question 3b. For the solution to question 3b, to find the length of the sides of the triangle, the length of AB, which is 4y, should be equal to 4 times 2.5, which is 10 centimeters. The length of AC, which is 6y minus 2x plus 1, should be equal to 6 times 2.5 minus 2 times 3 plus 1, which should be 10 centimeters again. Don't forget, this is an isosceles triangle and the length of AB is equal to the length of A to C, which are 10 centimeters each. While the length of BC, which is x plus 2y, should be equal to 3 plus 2 times 2.5. That should give us 8 centimeters. Finally, the lengths of the sides of the triangle are 10 centimeters, 10 centimeters, and 8 centimeters. I hope the solutions to example 3 they are clear to you. Moving on, let's learn about the graphical method of solving simultaneous linear and quadratic equations. Please take note of these 3 points. Number 1. Simultaneous equations can be solved graphically by drawing the graphs of the two equations on the same axis. Number 2. Their points of intersection give the solutions. Number 3. If one of the equations is a quadratic equation, there are normally two pairs of solutions. Please take note of these 3 points involving the graphical method of solving simultaneous linear and quadratic equations. Let's see our fourth example. Example 4 on simultaneous linear equations. Solve the following simultaneous equations graphically. The first linear equation is x plus y is equal to 3, while the second linear equation is x minus 3y is equal to minus 5. Use a scale of 2 cm to 1 unit on both the x and y axis. Also prepare tables of values for both equations for values of x from -2 to 4. Let's see the solution to example 4. For the solution for example 4, tables of values for both equations are shown below. Since the graphs are straight lines from linear equations, it is necessary to plot only 3 points in each case. Let's see the table of values. For a table of values for the first equation, which is x plus y is equal to 3, we have it that when x is -2, y is 5. When x is 0, y is 3. And when x is 4, y is -1 in the table of values. Y in the table of values for the second equation, which is x minus 3y is equal to -5, we have it that when x is -2, y is 1. When x is 0, y is 1 whole number 2 over 3. And when x is 4, y is 3. Having known these values, let's draw the graphs for both equations. Graphs of both equations drawn within the same axis is as follows. Here is the graph of both equation 1 and 2. From the graph, we can see that the two lines from the linear equations, they intersect at point P. The coordinates for point P should give the solution to the simultaneous equation in example 4. The coordinates of the points of intersection of the lines give the solution to the simultaneous equations. From the graph, x is equal to 1 and y is equal to 2. I hope the solution to example 4 is clear to you. Moving on, let's see our final example for simultaneous linear and quadratic equations. Example 5. Use a graphical method to solve the equations. The first equation is a quadratic equation, which is y is equal to 2x squared plus x minus 2. While the second equation is a linear equation, which is y is equal to 4 minus 2x. We are solving these two equations simultaneously. Use a scale of 2 cm to 1 unit on the x-axis and 2 cm to 2 units on the y-axis. Also prepare tables of values for both equations for values of x from -3 to 2. Let's see the solution to question 5. Here is the table of values for the first equation, which is y is equal to 2x squared plus x minus 2. From the table of values, we have when x is -3, y is 13. When x is -2, y is 4. When x is -1, y is -1. When x is 0, y is -2. When x is 1, y is 1. And when x is 2, y is 8. Now for the second equation, here is the tables of values. For y is equal to 4 minus 2x. From the table of values, we can see that when x is -3, y is 10. When x is -2, y is 8. When x is -1, y is 6. When x is 0, y is 4. When x is 1, y is 2. And when x is 2, y is 0. I hope these tables of values, they are clear to you. What we have to do next is to draw the graphs of these two equations on the same axis. After drawing your graph, how will your graph look like? Let's see if your graph is correct. Here is how your graph should look like. The graph for y is equal to 2x squared plus x minus 2 should be a curve or a parabola coming from a quadratic equation, while the graph of y is equal to 4 minus 2x should be a straight line coming from a linear equation. From the graph, we can see that the lines for both equations, they intersect at 2 points, points A and B. From the graph, the coordinates of the points of intersection of the lines give the solutions to the simultaneous equations. That means the coordinates of point A and point B are the solutions to these simultaneous equations. The answers to these simultaneous equations are as follows. At point A, x is equal to minus 2.6 and y is equal to 9.2. And at point B, x is equal to 1.1 and y is equal to 1.7. I hope the solution to example 5 is clear to you. Talking about using a graphical method to solve simultaneous linear and quadratic equations. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic simultaneous linear and quadratic equations, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.